Okay, welcome to this session of physics, and here we are going to discuss about the solution to physics. And what we are going to look at here is linear momentum. So when you talk about linear momentum, what do we need to understand? We need to actually understand the definition of what momentum is. So when you talk about momentum, what are we talking about in momentum? We are going to relate momentum to impulse, and we are going to look into Newton's Newton's laws of motion, the Newton's law of motion, and we are going to see some other aspects, but basically we are going to start by discussing what momentum is, what impulse is, then we are going to talk about force and also the Newton's law of motion and how they are related to one another. And from here, we can see what we are going to start with. Like we said, the first thing is talking about momentum. How do you define a momentum? A momentum of a body is actually defined as the product of its mass and its velocity. Okay, I always want to have this short information so that we can understand and jot down something. So when you talk about momentum of a body is defined as the product as the product of its mass m and its velocity and its velocity its velocity. So and that's v. So and mathematically we can see that momentum is given as p equals to m times v, mass times volume. And from what we can see here, the unit of mass is kilogram, while the unit of velocity is meter per second. So the SI unit of momentum, the XI unit of momentum is kilogram meter per second. And momentum is a vector quantity. Momentum is a vector quantity, meaning that it has magnitude and direction. And also, we can also refer to the unit of momentum as in Newton seconds. Newton seconds. We are going to see how it is Newton seconds as well. So from here, let's see what we have as impulse. What do we understand by impulse? Impulse can also be defined as the product of force and time. The product of force and time is what we refer to as impulse. So impulse is defined as the product of a force and the time. The product of the force and the time during which it acts on the body. It acts on a body. So you can see we have this also. It acts on a body. And it is also called, also equals to the change in momentum. And we are going to see that when you are doing the calculation under the momentum. And from here, like we said, it is also equal to the change in momentum produced by the force. Like we said, we are going to still establish that fact. Now, going back to what we said about the momentum, and we are going to also discuss the laws. What are the laws that we have under motion? That is Newton's law of motion. So we have basically three laws under Newton's law of motion. We have the first law, the second law, and also the third law of motion. So Newton's first law of motion, what does that state? And the Newton's first law of motion states that everybody continue in a state of rest or continuous motion in a straight line unless compelled or acted upon by some external forces to act otherwise. So I can give you that in what we have here, that first law Newton's first law of motion states that everybody continue everybody continue in its state of rest or of uniform motion in a straight line unless compelled compelled by an or by some external force by some external forces to act otherwise. So this is what the Newton's law first law states, that everybody continue in a state of rest or uniform motion in a straight line unless compelled by some external forces to act otherwise. And looking at this, when a body continues to be in a state of rest, if you have a body in a state of rest, let's say you have a body just like where you are, you have a book on the table, and probably you leave the book and for a month on that same table, the book will continue to remain on that table for that period of time. And unless it is acted upon, probably there is a force, it can be different external force that acts on it. And once a force acted on it, it's going to change position. So what makes it to change position is because of the forces that have been or that have acted on it. And that is what the first law states. Also, you say when a body is in a continuous motion, when you roll an object in a continuous motion, the object continues to roll, to roll, unless it is being acted by force. Now, the force that can act on this object can also be frictional force. So whatever force that acts on it that make the object to come to rest, it is because of that force that make the object to come to rest. That's why we say that every object or everybody continues in a state of rest or uniform motion in a straight line unless it is being compelled by some external forces. So as you can see, that is what we have under the first law, and we can look at what we have under the second law before we now go into what we have discussed previously under momentum and impulse. So the second law, the Newton's second law, states that the Newton second law states that the Newton second law states that the rate of change of momentum, the rate of change of momentum, rate of change of momentum of a body is proportional to the applied force. And takes place in the direction in which the force acts So from here we could see what the second law states, that the rate of change of momentum of a body is proportional to the applied force and take place in the direction in which the force acts. And from here we could see that the force is proportional to change in momentum or rate of change of momentum, and that is, like we said, P2 minus P1 over T. So in this case, we have established the fact that our momentum is equal to mass times velocity. So for P1 is going to be the mass times V, and for P2 is going to be mass times U. Now, mass times U and mass times V, this is final. So mass is a constant, mass does not change. So it is only the velocity that changes, and that's what's being about the change in momentum. So from here, we could express this as F is proportional to mv minus mu over T. So mass is constant, and here when you say F is equal to K into brackets mv minus mu over T. Now the value for K here, which is constant, is assumed to be equal to 1. K is assumed to be equal to 1. So from there we could see that our F is equal to mv minus mu divided by T. Now going further, we can derive something from here. That means F is equal to m is common. That is V minus U over T. So F is equals to m times A. F is equals to m times A. That is force equals to mass times acceleration, just like what we can see here. Now for the third law of motion, that's we have the Newton third law of motion. And this states that the Newton's third law of motion states that whenever a force acts, that means whenever a force acts on one body, comma, we see that an equal and opposite force act on act on some other body. Now, in other words, you can have it that in other words, to every to every action, to every action, there is an equal and opposite reaction. There is an equal and opposite reaction. So from here we could see that this is what the third law states, and mostly we also state the second part of it, that to every action there is equal and opposite reaction, and that is what we also have under the third law of motion. And as we can see that we have explained the other part in terms of force. If an object of mass and with initial velocity is acted upon by a force and it will attain the final velocity, then there is change in momentum. Change in momentum, as we have established, that change in momentum, change in momentum is also equals to impulse. And how do we see that? We see that our F, we said, is equals to mv minus mu over t. So we have defined a cross multiply from here. What you are going to have is ft is equals to mv minus mu. So ft is the impulse. That's the impulse. This is the impulse. And mv minus mu is the change in momentum. Change in momentum, as you can see that way. So that's what we have about what we can talk about: impulse, momentum, force, and the Newton law of motion. And before we dive straight into the equation or question under this aspect, um, we have established the fact that impulse equals to change in momentum and that force is equals to mass times acceleration, and then force, is equals to change in momentum over time. So let's see what we have under the calculation aspect of this.